On your screen you can see the natural exponential function y equals e raised to the power x. E is Euler's number and it is approximately equal to 2.71828. I will go into depth about Euler's number in a different video. But what is its derivative? The natural exponential function has a very special property. The derivative of y equals e raised to the power x is e raised to the power x. But don't click off this video just yet, because there's a lot more to it. Let me show you using some examples. On your screen we have the function y equals x raised to the power 2 plus e raised to the power x. We can find the derivative using the power rule. Because the derivative of x raised to the power 2 is 2x and the derivative of e raised to the power x is e raised to the power x, we find the answer 2x plus e raised to the power x. Let's move on to the next example. Now we almost have the same function, but instead of adding e raised to the power x to x raised to the power 2, we multiply it with x raised to the power 2. We have to use the product rule to find the derivative of y. The answer is 2x multiplied by e raised to the power x plus x raised to the power 2 multiplied by e raised to the power x. This answer can be calculated by taking the derivative of x raised to the power 2 and multiplying that with e raised to the power x. After that we add the multiplication of x raised to the power 2 and the derivative of e raised to the power x, which of course is also e raised to the power x. Now that we know this, we can make it a little bit more difficult. On your screen you can see the natural exponential function y equals e raised to the power g of x, in which g can be any function. The derivative of y can be calculated by multiplying e raised to the power g of x by the derivative of g of x. Let's make this clear using an example. You can now see the function y equals e raised to the power minus 2x on your screen. The derivative of y is then e raised to the power minus 2x multiplied by the derivative of minus 2x, which is minus 2. The final answer then becomes minus 2e raised to the power minus 2x. The last example that we will cover today is y equals the square root of e raised to the power 5x. We can solve this problem using the chain rule. If you don't already know how the chain rule works, I've linked to a video which explains it in detail in the description and on the top of your screen. We can say that y equals the square root of u and u equals e raised to the power 5x. The derivative of y with respect to u is 0.5u raised to the power minus 0.5. The derivative of u with respect to x is 5e raised to the power 5x, using the same logic as in the previous example. The derivative of y with respect to x is thus 0.5u raised to the power minus 0.5 multiplied by 5e raised to the power 5x, and is therefore 0.5 multiplied by e raised to the power 5x raised to the power minus 0.5 multiplied by 5e raised to the power 5x when we substitute for u. This gives us a final answer of 2.5e raised to the power 5x multiplied by e raised to the power 5x raised to the power minus 0.5. That brings us to the end of the video. If this video was helpful, please consider subscribing and liking. It would really help me out. If you want to help me out even more, check the link in the description. If you want to learn more about derivatives, check out the video on your screen now.